I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I am going to discuss about problems on formation of partial differential equation. So, already we discussed about the partial differential equation in previous videos. So, what is the partial differential equation and how to form the partial differential equation and what are the applications we are having in partial differential equation. These are all contents are covered in previous videos. So today in this video, I am going to discuss about the problems on formation of PDE by eliminating arbitrary functions. So first of all, here two methods are there to form the partial differential equation. So here the two methods are, first one is by elimination of arbitrary constants and second one is by elimination of arbitrary functions. So by eliminating arbitrary constants already we covered in previous videos. So today I am going to discuss about elimination of arbitrary functions to form a PDE. So first of all, what is PDE? Already we know what is the partial differential equation. An equation having two or more independent variables. The differential equation, we should have the two or more independent variables. So based on that, we are going to do the partial differential equation. That example we can write here dou z by dou x plus dou z by dou y equal to some x like this. So we should have the partial differentiation in the equation. So here we are denoting with dou for the partial differentiation. So here, so how to form this partial differential equation? By eliminating arbitrary functions. We are going to see in these examples. First, see the question. Form the partial differential equation by eliminating arbitrary function. Here the function is given pi. From the relation pi of x comma y comma z comma x square plus y square plus z square equal to 0. So first of all, what we have to write according to the procedure? First we have to write the given equation. What is the given equation? Given function is pi of x comma y, x and y and z, that is x y z, comma x square plus y square plus z square is equal to 0. So this is in the form of f of u comma v equal to 0. So this is the solution of the equation for the like this. So here if you are having this form, we can write this one as u equal to f of v. U equal to f of v. For example, here if you are taking u is xyz and v is x square plus y square plus z square. According to this form, I can write this one as xyz equal to pi of x square plus y square plus z square. So this is the equation. So I am taking this one as equation 1. So what is the procedure we are going to follow to form a PDE for the eliminating arbitrary functions or eliminating arbitrary constants also? We are going to follow two steps. We have to differentiate the given equation with respect to x, and after then how to differentiate given equation with respect to y. So after that we are going to do the simplification. We are going to do the simplification to form a PDE. So we are following these three steps to form a PDE here. First, this is the equation 1. What is the first step we have to do? Differentiate partially. So partially means partial differentiation. Partially with respect to x. First we are doing partial differentiation with respect to x for the equation 1. So then equation 1 implies, so x we are doing with respect to x, right? So y and z both are constants. X is 1 is equal to, so derivative of pi is pi dash of x square plus y square plus z square, and derivative of 2x square is 2x plus y square is over, this is the constant, so 0. Z square is also constant, no. So here z is a function of x and y. You should not take that one as a constant. So that's why here z square derivative is 2z. For the z is 2z by 2x. This is the important thing you have to remember in the partial differentiation. So in the partial differentiation, you should remember z is the function of x and y. This is not the constant. So now y and z. So here, what I told you here for the y and z, these two here, this is the constant, right? So when you are taking y is the constant, z is not a constant. Then what will become here? So here some change will be there. So y is the constant and we have to do the differentiation for x and z. So here u into v formula. So x and dou z by dou x plus z and x derivative is 1. So finally, what is the value here? Y into x, dou z by dou x is p plus z is equal to pi dash of x square plus y square plus z square into 2x plus 2z into p. So why we are writing p here? Already we are having the notations for the dou z by dou x. Dou z by dou x is nothing but small p, and dou z by dou y is nothing but small q, and dou square z by dou x square is r, dou square z by dou y square is t, and dou square z by dou x dou y is s. So like this we are having some notations. That's why we are replacing here p. So finally y into xp plus z is equal to here pi dash of x square plus y square plus z square into here take the 2 common x plus zp. This is the equation 2. This is the equation 2. Now first step is completed. So next step what we have to do? We have to do the partial differentiation with respect to y. So then differentiate partially with respect to y. So then 1 becomes here we are doing with respect to y. So x is the constant. So here y dou z by dou y plus z into y value is 1 equal to pi derivative is pi dash. So pi dash of x square plus y square plus z square. So here x square is constant, so 0 plus y square is 2y plus 2z into dou z by dou y. So now according to the notations, in place of dou z by dou y, I can replace q here. So x into yq plus z is equal to pi dash of x square plus y square plus z square 2 into y plus z into q. So this is the equation 3. Now I am doing the third step, that is the simplification. So 2 divided by 3. Why I am doing this all those steps? To eliminate the arbitrary function. So what is the second equation I am having here? Y into xp plus z by here this value is x into yq plus z is equal to, here from the second equation we can write pi dash of x square plus y square plus z square into 2 into x plus zp. 2 into x plus zp by this one is pi dash of x square plus y square plus z square 2 into y plus zq. So pi dash of x square plus y square plus z square cancel. 2 will be cancelled. So finally here y into xp plus z by x into y cube plus z is equal to x plus zp by y plus zq. X plus zp by y plus zq. So now we can do the cross multiplication to get the PDE form. So now this equation becomes y into xp plus z into y plus zq is equal to x plus zp into x into y cube plus z. Now do the simplification. So xy into p plus yz into y plus zq is equal to x plus zp into xy cube plus xy cube plus xz. Now multiply with the y. So xy square p plus y square z. And now this is over. Now multiply with zq. So plus xy z pq plus y z square cube. So this simplification is completed. Now we are going to multiply these two terms. So first with the x. So x into xyz is x square y cube. Next plus x square z. Next here plus next with the zp. So x, y, z, x, y, z, pq plus x, z square p. So now I am sending all this term to LHS part. X, y square p plus y square z plus x, y, z pq plus yz square cube. This one minus x square y cube minus x square z minus xyz p cube minus x z square p is equal to 0. Now xyz pq and xyz pq is cancelled. This one is plus, this one is minus. Next one is here we are having x square z. So here x square zp. So I will take the common. First of all, I am taking here xy square p. So what are the p terms? First we will take. So this one is x square p. And here any p terms are there, you have to check. So this is xz square p. Take the p common. So xy square minus x z square from these two terms. Next plus take the q common. Yz square minus x square y. So from this two. Next here take the z common. Y square minus x square from this two equal to 0. So this is our final PDE. So this is the way to eliminate the arbitrary function from the relation to form a PDE. Now we will see one more example here. Form a PDE by eliminating arbitrary function here also. So from the relation they given here f of x square plus y square comma x square minus z square is equal to 0. So now here from this first we will write the given equation. Given equation is f of x square plus y square comma x square minus z square equal to 0. So now I am writing the equation form. Already we are having the form f of uv equal to 0. From this I can write u equal to f of v. So what is the u value here? X square plus y square. So x square plus y square is equal to f of x square minus z square. So this is the equation 1. According to the procedure here, I can do the partial differentiation with respect to x and y. So first differentiate partially with respect to x. With respect to x. Now x square is 2x plus here y square is the constant. So 0 equal to f derivative is f dash of x square minus z square. And here x square derivative is 2x minus z square derivative 2z into 2z by 2x. Now 2x equal to f dash of x square minus z square. Take the 2 common, x minus z into 3. So 2 will be cancelled here. So finally x equal to f dash of x square minus z square into x minus zp. This is the equation 2. First step completed. The next coming step, what we have to do, differentiate partially with respect to y. So here, when you are doing with respect to y here, so one equation 1 becomes, so here x is constant, so 0 plus y square is 2y is equal to f derivative is f dash of x square minus z square. Here is x square is 0 minus 2z into dou z by dou y. Now 2y is equal to f dash of x square minus z square. Here minus z into q into 2. So 2 will be cancelled. Finally y equal to f dash of x square minus z square into minus zq. So this is equation 3. So first step completed and second step also completed. Now third step we are doing, what is that? Simplification. So here equation 2 divided by equation 3. What it comes? So second equation is x equal to f dash of x square minus z square into x minus zp by y equal to y f dash of x square minus z square into minus zq. So f dash will be cancelled. So finally x by y is, and that means here function is eliminated. Now x by y equal to x minus zp by minus zq. Now we are doing the cross multiplication. So x into minus zq is equal to y into x minus zp. So minus zxq is equal to xy minus zyp. Now I am sending this one to the RHS part, xy minus zyp plus xzq equal to 0. Now here xy z is the common minus plus z take the common. So xq plus yp is equal to 0. This is our partial differential equation. So this is the way to form a PDE by eliminating arbitrary function. Is it clear? So we are seeing one more example to form a PDE. Form a PDE by eliminating arbitrary function here in this relation. So first of all, write the given equation. What is the given equation? Given equation is f of x square plus y square plus z square comma z square minus 2xy is equal to 0. So this is in the form of f of u comma v equal to 0. From this, as it is procedure, I am writing u equal to f of v. So now what is the u? X square plus y square plus z square is equal to f of z square minus 2xy. So this is the equation 1. Now, what is the first step we have to do? Differentiate partially with respect to x. So that means here I am doing differentiate partially with respect to x. So now x square derivative is 2x plus y square is 0 plus 2z into dou z by dou x equal to F derivative is f dash of z square minus 2xy, and derivative of z square is 2z into dou z by dou x minus 2. Y is the constant, x is 1. Now I am simplifying this. Take the 2 common. X plus z into p is equal to f dash of z square minus 2xy into 2 into zp minus y. So 2 will be cancelled. So finally this is x plus zp is equal to f dash of z square minus 2xy into zp minus y. This is the equation 2. This is equation 2. So what is the next step I have to do? Differentiate partially with respect to y. So now differentiate partially with respect to y. So now equation 1 becomes, here x square is constant, so 0, y square is 2y, plus for the z square is 2z into dou z by dou y is equal to, now here f derivative is f dash of z square minus 2xy into, for the internal value, so 2z into dou z by dou y minus 2x is constant and x y value is 1. So now take the 2 common here, y plus z cube is equal to f dash of z square minus 2xy into, take the 2 common, z cube minus x. So 2 will be cancelled here. So finally y plus z cube is equal to f dash of z square minus 2xy into z cube minus x. This is the equation 3. So differentiate partially with respect to x and with respect to y, both are completed. Now what is the third step? Simplification. So here I am doing division, 2 divided by 3. So here I am following this method. If you want, you can use the another simplification also to eliminate the function. So what are the simplifications are possible? We can do all the simplifications. There is no difference. But we should follow the rules according to the simplification. So here second one is x plus zp by, here in the third equation, y plus zq is equal to f dash of z square minus 2xy into zp minus y by f dash of z square minus 2xy into z cube minus x. These two here function is eliminated, cancelled. So finally I am getting here x plus zp by y plus zq is equal to zp minus y by zq minus x. Now I am doing the cross multiplication to get the equation form here. So x plus zp into zq minus x is equal to zp minus y into y plus zq. Now I am doing the simplification. So xzq minus x square plus z square pq minus xzp is equal to, first I am multiplying with the zp. So yzp plus z square pq minus y square plus into minus minus yzq. So z square pq will be cancelled. So finally I am sending the remaining values to the left side. So xzq minus x square minus xzp. Now I am sending minus yzp plus y square plus yzq equal to 0. Now I am taking the p common and q common here. First take the p common. So here minus xz minus yz plus, take the q common, xz plus yz plus here y square minus x square equal to 0. So this is the final PDE by eliminating arbitrary function in this equation. Is it clear? Okay, I hope you understand this. I am moving with one more example to get the better clarity of this method. So here also form a PDE by eliminating arbitrary function. So before in the equation we are having the form like this, f of u into v equal to 0 or pi of u comma v equal to 0. Now they given the form here lx plus my plus nz equal to pi of x square plus y square plus z square. Nothing but from this only we are writing u equal to f of v or u equal to pi of v. So that is only they given directly. So they can give any form. So we have to understand the question first. After then we have to follow the procedure to eliminate the function. So as it is procedure we are following here also. But one step is no need to do here because here already they given the form u equal to f of v. So given equation is lx plus my plus nz equal to pi of x square plus y square plus z square. Now already we are having the form u equal to f of v. So directly we can do the differentiation partially with respect to x and y. So first I am doing differentiate partially with respect to x. So now L into x value is 1 plus m into m and y both are constant. So this will become 0 plus n into z is dou z by dou x is equal to pi derivative is pi dash. So pi dash of x square plus y square plus z square. And for the inner part x square derivative is 2x, y square is 0 plus z square is 2z into dou z by dou x. Already I told you. So about the z, we should remember z is the function of x and y. This important point you should remember when you are doing the partial differentiation. So here L plus n into x. Dou z by dou x is p. So L plus np equal to pi dash of x square plus y square plus z square. Here take 2 common. So x plus zp. Now here the equation 2 after doing the differentiation partial with respect to x. Now differentiate partially with respect to y. With respect to y. So here L and x both are constant. So 0 plus m into y is 1 plus n into dou z by dou y is equal to. So pi derivative is pi dash. So pi dash of x square plus y square plus z square. And here x square is 0, y square is 2y plus z square is 2z into dou z by dou y. So now I am simplifying this m plus n into q. So here dou z by dou y is nothing but q is equal to pi dash of x square plus y square plus z square and take the 2 common. So y plus z into q. So now this is the equation 3. Now first 2 steps completed. What is the next step I have to do? I have to do the simplification. So now I am doing the division here. So L plus NP by M plus NQ equal to. The most of the questions by doing the division we are getting the simplification. In some of the questions you have to multiply with another value and after then you have to eliminate the function. So like that we have to analyze the given equation. So based on the equation only simplification will be depends. Okay. So here L plus NP by M plus NQ. So by here this will be pi dash of x square plus y square plus z square by pi dash of x square plus y square plus z square. Here in the second equation we are having 2 into x plus zp by Here 2 into y plus zq. So 2 will be cancelled. Pi dash of x square and y square plus z square will be cancelled. Now finally, what is the equation I am getting here? L plus np by m plus nq is equal to x plus zp by y plus zq. X plus zp by y plus zq. Now do the cross multiplication. So L plus NP into Y plus ZQ is equal to X plus ZP into M plus NQ. Now here multiply with the term. So L multiply with this term. So Ly plus ZLQ plus NPY plus NZ into PQ is equal to, now multiply this one, m into x plus nxq plus here zpm plus nz into pq. So here nz into pq, nz into pq will be cancelled and send the remaining terms to the LHS part. So ly minus mx plus ZLQ minus NXQ plus NPQ minus ZPM is equal to 0. So here take the P terms common. So what is the P here? NPQ, and here ZPM. Take the P common. So then here NQ minus MZ, and here Q take the common, so plus Q into LZ minus NX plus LY minus MX is equal to 0. So this is the final equation of PDE. So this is the way to eliminate the given function from the relation to form a PDE. See one more example here. In the same way we are going to do here in this problem also. So same procedure we are going to follow here like a previous problem. So write down the given equation. What is the given equation? That is xy plus yz plus xz is equal to f of z by x plus y. So here this is the equation 1. This is in the form u equal to f of v. So directly we can do the differentiation partially with respect to x and y after that simplification. So first we are doing differentiate partially with respect to x. Differentiate partially with respect to x. Now according to that we are doing here. So x is 1. So y is the constant, x is 1 plus, and here y is the constant for the z, dou z by dou x plus, here x and z into v form. So x into dou z by dou x plus z into x value is 1 is equal to f derivative is f dash of z by x plus y. Here u by v form. So x plus y whole square, and this is the v square, right? So v, so that means x plus y into derivative of u, that is dou z by dou x minus z into x value is 1, y is 0. So now I am simplifying this one, y plus p into y plus x into p plus z is equal to f dash of z by x plus y into here x plus y whole square, x plus y into p minus z. So now here this is the equation we got after doing the first step. Now second step we have to do. So what is the second step? Second step, partially differentiate partially with respect to y. With respect to y. So now x into y value is 1 plus z into y is 1 plus u into v formula here. So y into 2z by tau q plus x is the constant, 2z by dou q is equal to, so f derivative is f dash of z by x plus y into u by v form. So here x plus y whole square and here x plus y into dou z by dou y is q minus z into x is 0 and y is 1. So now finally this is x plus z plus y cube plus x cube. This is with respect to y, right? So here x cube plus y cube is equal to f dash of z by x plus y into here x plus y into q minus z by x plus y whole square. So this is equation 2 and this is equation 3. Now we are going to do the simplification. So according to the simplification, first we will do division. Equation 2 divided by equation 3. So y plus z plus, take the p common here, x plus y by here x plus z plus, take the q common here, x plus y is equal to f dash of z by x plus y by f dash of z by x plus y. These two will be cancelled. Remaining terms are there here. So what are the remaining terms? So that is x plus y into p minus z by x plus y whole square divided by this term. So that one I can write it as x plus y whole square by x plus y into q minus z. So these two will be cancelled. So finally what I am getting here, y plus z plus p of x plus y by x plus z plus q of x plus y is equal to, so these two are cancelled. What I am getting here, x plus y into p minus z by x plus y into q minus z. Now I can do the cross multiplication to get the equation of PDE. So in terms of P and Q. So this is the final PDE and this is the way to eliminate the arbitrary function from the given equation. I hope you get the clarity about this method. By eliminating arbitrary function, you can form the partial differential equation. For the more examples, you can refer these textbooks, Higher Engineering Mathematics written by B.S. Gravel and a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal and Higher Engineering Mathematics written by B.V. Ramana. So please take some more examples from these textbooks and practice it, and then you can get the full clarity about the elimination of arbitrary constants. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.